Hello, we're going over Saxon math. This is course 1, lesson 109. It's called corresponding parts, similar figures, and or triangles, I guess. Let's just get right into it because there's a lot of information here. If two figures are congruent, the word congruent means that their corresponding parts, which are their angles and their sides, match exactly. Means they're the same size. Example would be triangle ABC and triangle XYZ. So in this case, you can see they are congruent, and side AC is the same as side XZ. So side AC is the same as side XZ. You can see it's the same length. You can also see that side CB is the same as side CY, and you can tell that side AB is the same as side X to Y. So, and they also have the angles corresponding. So you can see that inside here, angle A corresponds to angle X. Those are the same angles, just like line segment, that's a line segment, AB corresponds to line segment XY. Measure of corresponding parts of congruent figures are equal. So when you have triangle ABC and triangle XYZ being congruent, you can tell what the perimeter of each of those triangles will be. Since side AB corresponds to side XY, then you can tell that the length of side AB is going to be 5 inches, because we see that side XY was 5 inches. Those correspond, so they're equal. So each triangle has sides that measure 3, 4, and 5 inches. That also tells us that we can see that this ZY is the same as this CB. So this would be 3 inches here, and this is the same as this one. So they all have the same. The perimeter then is just simply the 3 plus the 4 plus the 5, which adds up to 12. Same with this one. The perimeter of that triangle is 12. If two figures are similar, they have the same shape, but not necessarily the same size. Similar figures have equal matching angles, but they might not have the same size. So like triangles 1, 2, and 3 are similar. Triangle 4, this is one that stands out. That is not similar. It doesn't correspond to any of these. Similar is slightly different than congruent. We'll get into that more as the lesson progresses here. So corresponding parts, two triangles below are congruent. These two are congruent. Each triangle has 3 angles and 3 sides. The angles and sides of triangle ABC correspond to the angles and sides of XYZ. By rotating, translating, and reflecting triangle ABC, we could position it on top of triangle XYZ. Then their corresponding parts would be in the same place. So like this angle right here is the same as this angle. Angle B would be the same as angle Y, and you can see angle C and angle Z are exactly the same. You can also tell that angle line segment AB, that's from here to here, line segment AB, corresponds to line segment XY. That's this line segment. Line BC corresponds to line ZY or YZ, or line segment. And line segment AC corresponds to the last one, XZ. If two figures are congruent, their corresponding parts are congruent. So the measures of the corresponding parts are then equal. So let's just look at this, for example. If we have this, these are two congruent triangles, triangle ABC and triangle XYZ. If we were to rotate this, looks like we could rotate it and translate it, and we're almost there. If we rotate it, translate it, and then it looks like if we actually took this and mirrored it on the y-axis, oh, looks like we made a copy of it, but when we mirrored it on the y-axis, you see that it flipped it, or it's a mirror image of it, and that's now perfectly in line. You can see that everything was congruent then. Let me go back to this position here, and let me bring in, let's group all of those so that I can show you that. So you can now see that this X corresponds to the A. It's just backwards now. The Y corresponds to the B, angle B, and angle Z corresponds to angle C. Okay, and you can see that we had to rotate, we had to slide it or translate it, and we had to flip it or reflect it in order for that to work. But those are two congruent triangles. So let's look at example 1. These triangles are congruent. What is the perimeter of each? So to start with, you need to know that if they're congruent, because they are congruent, you know that this is going to be the missing side over here. So this 3 right here, this 3 is actually going to be this 3 right here. It's also that length. And this 5 over here would be on this one, 5 inches here. So now we know what the perimeter of each of these triangles are because they were congruent, which means they're the same size and the same shape. That means they're also the same perimeter. They'd also be the same area. So everything is exactly the same angles. But now we know what the perimeter is. If you know the perimeter, it's just adding up all the sides. So 3 inches plus 4 inches plus 5 inches would be 12 inches. So first you can rotate the triangle on the left if you wanted to rotate it, and then you would translate it, you'd slide it over, and you'd end up noticing that all of those sides are the same. You can more easily see that the unmarked side of on the left-hand triangle corresponds to the 5-inch side on the right triangle. It's a little easier to see. Oh, see this piece right here is what's missing over here. And you can tell this piece right here is what's missing information right here. And then all you need to do is add up all the sides to find the perimeter of that particular triangle. So if you have similar figures, that's figures that have the same shape but are not necessarily the same size. 3 of these 4 triangles are similar. And we've already seen this before, but you know that if it's congruent, they have to be the same size and shape. So if it's congruent, we're talking about the same size and shape. Well, actually, the size doesn't equal the shape. It's just that they are the same size and same shape. So more accurately. So these would actually be identical, but this is also congruent, or this would be similar in that it is not the same size, but it is the same shape. So congruent was what we learned about before. They're both equal. So these would be equal. These two would be congruent. But if we were to consider from going from this one to this one is now considered similar. This one, however, doesn't fit the bill. This triangle number 4 does not fit either congruent or similar. So these two right here are congruent. And then this one right here, these two right here, or the other, or even those two, those are similar. So similar is a little bit different. It just means they have the same shape, but not necessarily the same size. So that's the difference between congruency and similarity. Triangles 1 and 2 are similar. They're also congruent. Remember, congruent figures have the same shape and size. Triangle 3 is similar to the triangles 1 and 2. It has the same shape. You can see the angles are going to be the same. All the angles will actually be the exact same measure, but they're not going to be the same size as triangles 1 and 2. And then the corresponding angles of similar figures have the same measure. Triangle 4, however, is not similar to the other triangles. Can we reduce or enlarge triangle 4 to make it match the other triangles in the diagram? So can you make this larger or smaller to make it match any of these? Hopefully you would know that the answer is no, you cannot. And you cannot match it because it's not similar. No, because triangle 4 is not similar. If it was similar, then you could actually match it. Then it would be congruent. So this congruent triangle 3, we could actually reduce the size of it and make it congruent. Since it's similar right now, we could change it from being similar to congruent if we reduced its size. Or if we made triangles 1 and 2 larger, that would make them congruent to triangle 3. So here's two important facts about similar polygons. In this case, the corresponding angles of similar polygons are congruent. So when you look at two different polygons, and if they're similar, their angles are going to be the same. The corresponding sides of similar polygons are proportional. So the sides will remain in proportion, but they may be different in size. So just going back to this, right here, you can see that this one is proportionate. This triangle right here is maybe twice as big as the triangle 2. The first fact means that even though the sides of similar polygons might not have matching lengths, the corresponding angles do match. The second fact means that similar figures are related by a scale factor. The scale factor is a number. Multiplying the side length of a polygon by the scale factor gives the side length of the corresponding side of the similar polygon. So like these triangles, for example, these are similar in that if we were to rotate this, if we rotated this one, we rotated this one, looks like we'd have to, the ones that are similar right now are these two. And until we were to reflect this one, it's not similar just yet. This one is similar. All we had to do is rotate it. And I guess this could be considered similar if we were to reflect it. If we mirrored on the y-axis, there's an example of it right there again. And I can't do anything with that right now, but this one is similar. If we were to expand its size, you can see that it would be closely matching, okay? But right now it's just smaller. So example 3, the two rectangles below are similar. What is the ratio of the corresponding sides? By what scale factor is rectangle ABC larger than rectangle EFGH? So if you look at that, you need to realize that first we find the ratio of the corresponding sides. In this case, you can see that side B to A, so if we were looking at this one, from B to A, Which one does that correspond with? F to E. Corresponds with F to E. So side B to A, or A to B, in relationship to side E to F is 2 to 1. Because you can see it's 2 centimeters to 1 centimeter. So that means that if we have, and we can also see that on this side right here, side B to C corresponds to side F to G, and that's also a scale of 2 to 1 because it's 4 to 2, which reduces to 2 to 1. In all similar polygons, such as these two rectangles, the ratios of corresponding sides are equal. The sides of rectangle ABCD are 2 times larger than the sides of rectangle EFGH. So rectangle ABCD is larger than rectangle EFGH by a scale factor of 2. So if we took whatever these sides are and multiplied it by 2, we'd end up getting this rectangle. So which of these triangles are congruent? Or it says these are congruent. What is the perimeter of each? So first of all, one thing you might want to do is get these to line up so that you can recognize what the sides match up to. So if I did this, I can see, oh, clearly that 15 and that 15 match up. And this side that I'm missing 2 sides over here, but this side is also 20 inches, and this side is also 25 inches. So these are congruent. That means they're the same size and shape. Size and shape are equal. So if the size and shape of both of these are equal, now we know what the perimeter is just by taking 15 plus 20 plus 25, which would be, let's see, 30, 40, that'd be 60 inches would be the perimeter of this triangle. And since this one is a congruent triangle, it's also the same. Here's some similar triangles. They have the same shape, but not necessarily the same size. The two that are similar, or would be, this one is similar to this one. It's also similar to this one. It is not similar to that one. These two triangles are similar. What is the measure of angle A? So that's what we're looking for. So before we figure that out, I'm going to take this piece. I'm going to do some rotating to get that to line up. It looks like I also need to do some translating or mirroring. I'm going to mirror it. And this is where it ends up. So I can see now that I've got these. And I can tell, okay, that actually needs to be, this A matches up to what I see is the measure of that angle right there. And you see, I didn't have to even know what the names of these angles are. But this being similar means the angles are the same. So this angle, you can see, fits right in there perfectly. This angle over here fits in there perfectly. This one's a 90 degrees, so that fits. So that means we know what angle A is then. We know that angle A in this case is going to be, so from here to here is the same as from here to here. So angle A equals 30 degrees. All right, let's give these a shot. Letter A, answer this for me. All squares are similar. True or false? If you answered true, you've nailed it. Why are all squares similar? Let me see if I can draw you a square. Let's look at, let's do this. Do this. Here's a square. There's one square. Here's another square. Here's another square. Here's another square. All those are similar. What is the definition of similar again? Well, if you go back to what similar means, similar is when two objects have the same shape, they have the same angles, but they have different sizes. Okay, remember that? They have basically the same shape, but they have different sizes. Squares are all the same shape. So all squares are similar no matter how big they are. Okay, let's move on to letter B here. All similar triangles are congruent. True or false? You should have answered false on this one. All similar triangles are not congruent. Okay, so if you look at, let's see, these two, these are similar triangles, but they're not congruent because they're different size and different shapes. Okay, let's do letter C. If two polygons are similar, then their corresponding angles are equal in measure. True or false? You should have answered true for this one. If two polygons are similar, then their corresponding angles are going to be the same. So like this, for example, this problem we did here. These polygons are similar. You can see the angles were the same. Angle A there, angle B, angle C. They're different sizes. Remember that? They're different sizes. Right? If we made that even smaller, it would still be the same. You'd still end up having the same, should have the same angles and everything. But they're different sizes and same shape. So they're similar. So in answering this one, it would be true. Letter D, these two triangles are congruent. Which side of triangle PQR is the same length as side AB? So if we were looking at triangle PQR, that's this triangle here, and we're trying to figure out which one matches up to this side AB. So which one over here is the same? Is it this one, or this one? Okay, if you answered QR, it's a line segment QR, or you could have labeled it RQ for the line segment. You would have been correct. See this one right here matches up. You see it's shorter. It's pretty clear on this particular one. Letter E, which of these two triangles appear to be similar? So you need to name two of them. And if you said triangle 1 and triangle 2, you would actually be correct. It's these two. The only thing you would have to do here would be flip it or reflect it and translate it, slide it over, and they would be similar. They're the same. You see this 90 degrees is the same as this 90 degrees. Whatever this measure is going to be exactly the same as that measure. Whatever the measure of this angle is going to be the exact same as that measure. This one's not. Why? Because, well, you can tell this angle right here is a lot smaller than any of these angles. That's a really small angle. This one's a little different. So it just looks different. You can see the angles aren't quite the same. It only has one angle. It has a 90. The rest of these angles aren't going to be like the others. Letter F, these two pentagons are similar. The scale factor for corresponding sides is 3. How long is segment AE and how long is segment IJ? So we're looking for segment A to E. How long is this segment? And we're also looking for I to J on this one, on this side. Okay, so what do we have to look at? So let's start with this question. How long is segment A to E? So line segment A to E, it's not 9. This doesn't just translate straight over, right? But it does have a ratio. We're going to have to figure out what that ratio is. And if we look at this, it seems to me like you can tell that this side would be 3 inches, because if you were to look at it, you can tell that it's got scale factor of 3. Since it's got a scale factor of 3, that means we just take 9 divided by 3. So that means line segment AE equals 3 inches. And then if we recognize that, if this is 1 inch over here, all we have to do is multiply that by 3 to get that distance. So that means we know that the line segment IJ is going to be the same as 3 inches as well, because 1 times 3 equals 3. All right, I know it's kind of a long lesson, but now you can do these quiz questions, answer them in your Go Formative by midnight tonight, and we'll see you guys next time. Thanks for watching and answering.